Hello, in this WAGO tutorial we'll show you how to operate a complex module on a fieldbus coupler. Before we dive into the configuration, the first question that comes up is why complex modules cannot simply be used on a fieldbus coupler like a module with digital inputs. Complex modules are modules with special functions. For example, serial interfaces, DALI, KNX, or the WAGO 3-phase power measurement module. Because their functionality depends heavily on the specific module design, CODESYS does not initially know which functions are available or how to access them. So we first need to teach CODESYS how such a module is to be used. For this, the module manufacturer provides suitable libraries. By the way, even for complex modules connected directly to the controller, such a library is required. However, in that case, it is automatically included. In our test setup, the serial interface is initially connected directly to the controller. And we can see that the library WagoSysModule 75x65x has been included. This contains the function blocks for the respective modules, including the function block for the serial module 75652. Now, however, we want to use this module on a fieldbus coupler, for example the EtherCAT coupler 75354. To do this, we first need to configure the EtherCAT communication. A detailed explanation can be found in this video. After loading the program onto the controller, the EtherCAT master can search for connected devices. In addition to the digital I/Os, the serial interface is also detected. If we expand this item, we can see, because EtherCAT transmits data byte-wise, the 24 input bytes and 24 output bytes. With digital I/Os, this would be straightforward. Map variables and you're done. For the serial interface, however, it's not that simple. For example, if we want to use it as a Modbus RTU master, we cannot simply attach a Modbus client, as it communicates exclusively via a COM port. For this use case, WAGO provides the library WagoSysFieldbusModule. It contains all complex WAGO modules, allowing them to be used as if they were connected directly to the K-bus. First, we create an array of bytes for all input bytes and another for all output bytes. Then we switch to the serial module and link, in the I/O mapping, for example, the first output byte to the corresponding array. Because we must supply a byte at this point and not the whole array, we also specify the array index of the first byte in square brackets. Because we need to do this for all 24 output bytes and all 24 input bytes, we copy the entry, paste it into the PLC-PRG 24 times just for editing, and adjust the array indices. After that, we copy the entire block back into the module's I/O mapping. For the inputs, this is particularly quick, because by holding the Alt key, we can select vertical blocks of text and replace the marked out entries with in. Cut, paste, and we have captured the complete module image in 2 arrays. In the next step, we need to pass these arrays to the appropriate function block from the WagoSysFieldbusModule library, which turns them into a usable serial interface. In the declaration section, we open the input assistant with F2 and search for WagoSysFieldbusModule. Here, all function blocks for the complex WAGO modules are listed. We select the function block for our 652 module. It's highly recommended to use a name prefix here. Even though the block is unique in our case, if a 75652 module were also connected to the K-bus, the function block from the WagoSysModule 75x65x library would otherwise be called. The fact that both function blocks have the same name is intentional. The base functions are indeed identical. Only the communication layer above provides the specialization for K-bus or fieldbus coupler operation. Since we are accessing only the I port, we name the block I652. We can now call the block's various methods. For passing the input array, we use the method setNewPAInput. We need to provide two details: the address of the array and its length. In our case, the length is fixed by the module, so we enter 24. For dynamic lengths, we could also use PA size input. We do the same for the outputs using the method getNewPAOutput. The serial interface is now fully initialized. Next, we include the block simple Modbus master serial from the WAGO app PLC Modbus library. We use the supplied example, both the declaration section and the program section. We place the program code between setNewPAInput and getNewPAOutput, keeping a clear structure. First read inputs, then process, and finally write outputs. We now need to assign the I port. That is our function block I652 from the WagoSysFieldbusModule library. With this, the programming is complete. A keynote. In the declaration section, the trigger interval for the next Modbus request is set to 20 milliseconds and the timeout to 50 milliseconds. These are typical real-world values. However, our PLCPRG task runs with a cycle time of 100 milliseconds. If we started the program like this, we'd immediately get a Modbus timeout in the first cycle, and the intended 20 millisecond polling interval would not be achievable. So we reduce the task cycle time to 10 milliseconds, and the program runs correctly. After uploading and starting the program, the EtherCAT communication initializes, and the Modbus master begins polling. Because there is no slave connected in our example, we naturally get a timeout. But this comes from the missing Modbus response, not from any issue in the task system. This approach can also be applied to other couplers and modules. In another example, we use a PFC300 with the Modbus coupler 75362. Here we have the DALI module 753647, including a power supply, as well as the three-phase power measurement module 75494 connected. First, we configure the communication with the Modbus coupler and set up a Modbus channel with function code 23 to read the entire node. How this works in detail is explained in this video. In the coupler's web-based management, we see that the entire node consists of 25 input words and 25 output words. The DALI module occupies words 0 to 11, the measurement module words 12 to 23. Digital I/Os are also present. As in the EtherCAT example, we create arrays. This time arrays of word, because Modbus works with words. 2 arrays for the DALI module and 2 for the measurement module. We then map the array positions to the channel positions. In the PLC-PRG, we declare the function block for the DALI module and the block for the 494 measurement module from the WagoSysFieldbusModule library. In the program window, we simply call the methods setInputs and getOutputs, providing address and size. The size must always be given in byte. Since we have 12 words, we enter 24 bytes. For the DALI master, we use the master block from the WAGO app DALI, and for the 700-494 measurement module we use, for example, the compact block from the WAGO app Power Measurement. We'll skip the assignment and declaration of the function block variables this time, as everything has already been fully declared and assigned. The I-port for the DALI master is therefore the I647 function block, and the I-port of the three-phase measuring terminal is the I494 function block. Once we log in and start the controller, the DALI status switches to OK, and on the three-phase measuring terminal we also receive data, although mostly zeros, since nothing is connected to it. This means the complex modules on the Modbus coupler are now configured so that they can be used as if they were directly connected to the K-bus. There's one particular detail you need to be aware of. The communication between the controller and the coupler is exclusive for as long as it is active. This means we cannot use that connection, for example, to link up with a configurator or I/O check. With the DALI configurator, for instance, you will then see the error message interface error. If this connection is to be used for configurators, communication via the master function block must be deactivated, for example, by stopping the controller. Only then can a connection between the configurator and the coupler be established. And that brings us to the end of this tutorial on how to operate a complex module on a fieldbus coupler. Feel free to give us a thumbs up if the video was helpful, subscribe to the channel and contact the WAGO Support Center if you have any questions.